the slope, no matter what it says. Okay? All right, so let's read the problem. Joanna jogs a straight path for time 0 to 40, so she's jogging for 40 minutes. Joanna's velocity is given by a differentiable function v. Notice, we're in velocity already. Okay? Selected values v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Okay, so they gave us some data in the table. Use the data in the table to estimate v prime of 16. So all we're going to do is find the slope. So you find the numbers that surround 16. See these x values? 16 would be between them, right? And we're going to calculate the slope of the line. Okay? So what are your y values? 200 and 240. So I'm going to go 240 minus 200. And what are your x values? 20 minus 12. And this is a question 3 in 2015. This would not be on calculator. Okay? So what's 240 minus 200? 40. And 20 minus 12? 8. So 40 over 8 is 5. Always label it whether it tells you to or not, because there could be points from the labeling. Okay? Probably not because it's not stated that way, but let's make sure that we know what we're doing. So 5 what? Nope.
Meters per minute.
Close to the meters per minute. Meters per minute squared, because I started in meters per minute and I took its derivative. So that's where the squared comes from. It's meters per minute per minute. Yes?
Why'd you subtract the numbers?
Because I was using y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's how the formula for slope of a line. Okay? You got 1 point for doing that. 1 point is better than no points. Okay? So as long you got that 5, you got a point. All right, we good with part A? Okay, let's look at part B. I'm going to switch slides. Using correct units, explain the meaning of the definite integral in the context of the problem. Approximate the value of the absolute value using right Riemann sum with 4 subintervals as indicated in the table. Okay, I'm going to do this part first, and then I'm going to come back to explaining the meaning. Okay? I still need to do the explaining the meaning, but that's worth a point, whereas the Riemann sum part is worth 2 points. Okay, a part for setting it up and a part for the approximation. All right, it's talking about absolute value, so we have to take that into consideration, because notice it says absolute value in there. Technically what we're doing is we're going to set up the integral. I'm going to try to squeeze it in up here. From 0 to 40 would be the notation of the absolute value of v of t dt. Okay? All right, we're talking about a right Riemann sum, meaning I'm coming from this direction. How many subintervals am I supposed to have? 4. Okay, so I'm going to do 1, 2, 3 plus signs. So that way I know that I can fill, once I filled it in, I'm done. What is my first distance in between?
40 minus 3.
Which is 14. No, not 14, is it? 16, isn't it? Okay. All right. Then my first height would be 150. And it's rare to have consistent values in here. If it's consistent values, you're probably doing a midpoint. Okay? All right. What's my next distance in between? 14. No, just 4, right? What is wrong with our subtraction today? All right. And technically, we're supposed to be taking the absolute value of the height. So what would be the absolute value of this? 220. Okay. And then we've got the distance in between this would be what? 8. And what would my height be that I'm using? 240. All right. And then the distance in between this is 12, and my height I'm using is 200. Yes, the expectation was to do that without the calculator. In theory, you could probably stop there and they would give you the points. Okay, but they do say they want you to approximate it. So this morning, I know it's Monday, go ahead and use your calculator. Okay, even though we're not supposed to on this one. You can grab one. It's okay. All right, we got a number yet? 7,600. And what should it be labeled in? So what I did was I just integrated. So I went from velocity back to a position thing. So if I'm going to integrate, don't I get rid of this piece? So it should be just be in. Okay, now that we know what the label is in the approximation, now let's talk about the meaning of it. Okay? So what I just did to integrate was I went from velocity to position. Okay? But there was another little piece of it. You see how it has those absolute value marks around it? So what that means, because if I just went to position, if it starts here and it does this and it ends here, which is what happened, right? It went backwards at some point. I only get from the beginning to the end. I don't get this negative space. When I put the absolute value on it, I take into account that negative space. So I take into account the total distance traveled. So that's the key to the explanation, okay? Is that it's the total distance traveled in over how many meters. But you have to put it in the context of the problem. So what's happening in the problem? She's jogging. Okay, so we would say that, I'm going to put it down here at the bottom, 0 to 40 of the absolute value v of t dt, okay, is the total distance Joanna jogs in meters over the time interval, so over the interval, that says interval from, where do we start, 0 to 40, and that's good. Oh, you might want to label it minutes, right? The other one that comes up sometimes is sometimes they'll do the 1 over b minus a out front instead. And then that just means you're doing the average value of whatever the problem is. Okay? So those are the two things that tend to come up for an explanation on those. All right, we good with part B? So part B, you got a point for your explanation, a point for setting up the Riemann sum, and a point for evaluating it. Okay? You're going to have a Riemann sum of some kind. It might be a midpoint. It might be, the more of them boxes there are, the more likely it is a midpoint. Okay? Just depends on the year, and there's no way to predict which, if you're getting a trapezoid or a midpoint or a right or a left this year. So, all right. So part C. Bob is riding his bicycle along the same path. Okay? So same path as Joanna. Bob's velocity is modeled by this function, so they gave us a function. Okay? Where t is measured in minutes. B of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. So what is Bob in right now? Velocity. So how do I get to acceleration? You do the derivative, right? See, this is why I can't show you free response problems at the beginning of the year, right? Because we have had to integrate and do a derivative all in one problem. Okay, and know how to go back and forth between the two. All right, so I'm going to take the derivative of that. What's the derivative of it?
3t squared minus 12t.
12t. I don't need the plus 0, right? We took this was a velocity function, right? Because it told us it was a velocity function. In order to get to acceleration, we know we take the derivative of velocity. Okay? All right. What am I supposed to do? Plug in a 5. So b prime of 5 equals, what's 5 squared? 25. 5 times 12 is 60. 3 times 25 is 75 minus 60 is 15. We just went to acceleration. What would I label it with?
Meters per second squared.
Meters per minute squared. So you got 2 points for that. 1 point for calculating your derivative and 1 point for the answer. Okay? Did I need to do part B to do part C? No. All of these are independent of one another, and you'll find that on a lot of problems. So just because you maybe can't do part B, don't skip part C and D. Go and read them and make sure you don't know how to do them before you skip them. Okay? I know. All right. the last thing is, and this typically pops up in this type of problem too, it says, based on the model B from part C, find Bob's average velocity during the interval from 0 to 10. Okay, so there's two things that we have to tend to run around. One of them is average rate of change. It will literally say those words, average rate of change. That's slope or your first derivative, right? The other thing is average and pretty much anything else. And the other key to seeing this is that, see how they gave you an interval? When they give you an interval, what do you need to do? No. We integrate it. Whenever they give you an interval, because those are your limits on your integral, right? So 0 to 10, okay, of this function that they gave us here. I need to do average velocity. Remember, that's the 1 over b minus a thing. So 1 over 10 minus 0 goes out front. You're going to see it pretty much on every one of these type of problems. Okay? It's just going to be, it might be in a different part of it. It won't always be part D. All right, and then I've got to integrate this function here. So t cubed minus 6t squared plus 300t, or 300 dt. All right. When we integrate t cubed, what do we get? T to the 4th over 4 minus what? Divided by 3, which is really 2t cubed, right? Plus what? Plus 300t. And we're going from 0 to 10. What am I going to plug in? 10. Do I need to worry about the 0? Not in the position it's in right now because it's on the bottom, right? All right, so that basically means I just need to add that many zeros, right? So I need 4 zeros after this one. So 1, 2, 3, 4 over 4. Minus, I just need, it's going to be 2,000, right? Because I need 3 zeros for cubed. And then I need to add an extra 0 to the 300. All right, again, you wouldn't be using your calculator, but it is Monday morning. So if you want to use your calculator, find me a number. I like 350. Now, I want you to look at what we're actually calculating here. It says we're calculating average velocity. What should my label be? Meters per minute. So meters per minute. Okay. All right, let me see. I think I went back to 12. 11. Okay, let's do the trapezoid. I don't think I assigned 11 tonight. Let's see. All right, we good with that one? You want to try one more together? Okay, let's try one more together. I'm gonna make sure it's not one that I have assigned tonight. So we haven't. I assigned 14, 13, and 12. So let's do 11. So page 201. Okay.